Okay, so next, so this is the surfaces that we've done so far. For 3 traces on the spheres, I already shared with you how to sketch some spheres previously. So next, maybe I give you another equation where the total variable is 3. Okay, so next, what is the shape of this particular graph? Okay, so first I just use this one. Okay, and then now we have square root, and then the third one, okay, a bit different. The third one, x squared over 9 plus y squared over 4 minus z squared equal to y. Okay, so now next we start with this particular equation. So you can see that the total variable is 3, so the total trace, there are 3 traces, just like you've done in finding the, or how to sketch the spheres. Okay, so we have just now z equal to x squared plus y squared. Since you have to provide 3 traces, which means that you have to have set the trace on x0 plane, so we have z equal to y squared. So the graph is, we have a quadratic shape on zy plane. Okay, and then y equal to 0. So y equal to 0, we have to substitute y equal to 0, so z equal to x squared. So your second trace on zx plane is also the same quadratic. Okay, and then we have z equal to 0 plane. So x squared plus y squared equal to 0. So now when you sketch that on y-x plane, so what is actually the graph of this? Anyone can tell me? It looks like a circle equation, right? Circle centered at the origin, but the radius is 0. So no radius. Imagine you have a circle centered at the origin, but no radius. What is that? Yes, it is just a single point here. Just a point, a dot, 0, 0. Okay, so now, let's say you just provide that's 3 graphs. Then you want to join them all together on the 3D system, because we have 2 traces here, we don't have the projection. Okay, so now look at the first one, x equal to 0, meaning that your eye, you are watching from x-axis. Okay, let's say I want to use a standard orientation, x, y, and this one is z. Okay, so when you are looking from x, so you can see this green line on zy plane, zy plane. So you can see the, should use the same color, green, this one. Okay, from this side. So you just watch that using that direction, and you can see this line, or on 3D you have this, just a line. Okay, now we move to the second trace, which is to set y equal to 0. So what can you see on zx plane, where y is equal to 0? So y0 is over here on this wall on zx plane. So you can see the same quadratic shape, but now on zx plane. So we have a white curve. Okay, so it looks compressed because you are looking from this side. Okay, this one you look from the in front of here. This one just side. Okay, your side vision. So that's why it looks a bit compressed. But actually, the size of the quadratic, these two quadratics, they are the same. Okay. Okay, how about this point? So what is this? So you want to know what can we see right on the floor? So you set z equal to 0 and then you just got 1 point. Is it enough for you to conclude what is actually the curve that you must have on y-plane? So you just plot this dot. So I just plot that dot. So that is the dot. So we have no idea what is the shape. Meaning that what is actually happened. So when you are having something like this, so you are watching from Z. So you are standing over there and you're looking downward, but you can just see a single dot. The dot doesn't tell you anything about the curve that you must get from your sketching. So meaning that the information that is needed still incomplete. You have to do more in terms of what happened, what is the curve that you can see on the y-axis. Now at the moment, you can just see the single point. A single point, you know, what is a curve? Curve is the combination of very many points. Then you can have the curve. But if you have only a point, then how can you have a curve? So meaning that the sketching on y-axis is not enough. You have to do something else. Okay, so now let's say is this one we are investigating the shape right on the floor. How about, okay, look at here. How about if we increase the z? Just now it's lying exactly right on the floor. Now let's say we want to observe what is actually the curve when z equal to 1. Just lies over here 1, and then maybe 10 and maybe 100. Okay, you can try. So now let's say we start with the simple small number. So I put, so we back to the original function provided. So you can have z equal to x squared plus y squared. So just now you set equal to 0, meaning that when z equal to 0. Okay, so when z equal to 0, we just have a single dot. Okay, now how about, so let's say we use it for some specific z. So we have investigated z equal to 0 just now. So let's say now 1, and maybe 4, and then maybe 9, and many more. Okay, so let's say now we have 0, and then 1, x squared plus y squared. And then we have 4, x squared plus y squared. And so on. Okay, so what can you tell me? What can you tell other people? What is actually the shape when you increase the value of z? So look at the first. So this one will give you, you see that, okay, right on the floor, I just can see a dot. Okay, now you increase the z by 1. So now I can see a circle, right? This one is a circle equation where the center is at origin and the radius is 1. So you can see a circle, and this is another bigger circle. So now you plot. Okay, I replot. So I put here the what can you see on the y-axis plane? So now we have the first one just now. Z equal to 0, so you got a dot. And z equal to 1, you have a circle with radius 1. And then when equal to 4, you have a larger circle with radius 2. And then you can expect what happens next if you increase the z. So you will get always the circle. When you increase, by increasing the z, so your circle become larger and larger and larger. Okay, so now once you're done this, so you want to present to me without you sitting beside me to explain. You have to explain everything on the paper, right? Then you have to label so that I know which circle for which equation. Okay, so now you see that this one is z equal to 0, and the one is z equal to 1, and then you have to z equal to 4 just now, right? 4, and this one maybe, I don't know, maybe 9 and so on. So once you label, so I know which circle for which z value. Okay, so now you can see that. Okay, now we relate your sketching on the trace here with your graph by increasing the z. So you can see very many circles and the size become larger and larger. Okay, so meaning that if you have z equal to 1,000, a billion, you still have the circle, but you have a very large circle. So I would say that when you are standing up here, you can see a very many circles where actually you can see that. Okay, so where is this line actually? So now I draw it here. So just now z equal to 0 is right over on the floor, right over here, and z equal to 1. I set z equal to 1, so you can see a circle with radius 1, which is this one, and then you set z equal to 4. So let's say in the middle here you have 4, and you have a larger circle with radius 2, and then maybe you have instead of 10 you have 9. I don't know, you can put any number. Then this one's supposed to be okay. Oops, sorry. So just move on. So the 9 is not there, but the 9 is. This is 9. Okay. Okay, when you look downward, when you are looking downward, so you can see that this circle lying on xy plane, this circle here on the surface, which is what is the name of this specific surface? It's just like a bowl shape, right? A bowl shape. From that side you can see quadratic, from that side you can see the quadratic, but when you're looking downward, okay, you're standing up there and you're looking downward, you can see very many circles. And actually again, the size of your bowl, I would say bowl, actually this is called paraboloid. This is paraboloid, boloid. Okay, because on 2D we call that as parabolic, then on 3D we call that as paraboloid, something OID at the back. Okay, so or in a simple word we can say a bowl. So we can say that actually the size of this bowl is very large. Okay, really giant bowl. But then for the sake of just sketching, it is enough for just put don't need to very large, just so and easy for you to sketch, as long as I understand that you want to tell me you have a paraboloid. Okay, so now we know that this one is a paraboloid, concave up. Okay, so let's see now. Okay, now we done a sketching on the z equal to x squared plus y squared. Okay, but for this trace I've forgotten to tell you, you have a trace on y-axis plane, and you can see some levels of curve, isn't it? Whether you increase the z, so the size of the circle can getting larger, or in the other way around. Sometimes when you increase the z, and the circle becomes smaller and smaller. So it depends on your equation that you have. So this is called as level curve. So this process, when you provide some level of z, you increase the value or decrease the value of z, you can see some level of curve, so that is called level curves. So level curves is important. Actually, it is important for you, especially for the equation where the total number there is 3. Okay, just like what we went through just now. If you just set z equal to 0 at the beginning, then you just lost. You have no idea what is actually the shape. Sometimes it can be ellipse. Okay, sometimes it can be ellipse. So that's why we need to investigate. Okay, so in order for you to investigate, then you have to just manipulate the value of z. So that process is called level curves. Level, because you can see some level here becomes greater and larger, or smaller and smaller. Curves, because you sketch the graph on the 2D, so it's called curves, level of curves, or in simple word, level curves. Okay, so now let's see. In exam, I'm asking you to sketch z equal to negative x squared plus y squared. So now you compare the thing that we have done just now. We have z equal to x squared plus y squared. So what is actually the shape of this new equation that I gave you? Okay, without resketching, just thinking, and then you just convert on the graph. So I hope that you can see that if this one z equal to x squared plus y squared is a bowl concave up, okay, you can see that if this is the case of the function or the equation, so you can see the bowl concave up and parallel to z, because you have z here. Now instead of it is all z all positive and this one z always negative, meaning that you are actually having a similar bowl, but it is concave down, because the z is always negative. You put the x outside. So by resketching from the surface that you have obtained here, which is a concave up bowl, now you have to draw something concave down bowl. Okay, so it looks like something like that. Okay, that is your bowl, the same bowl, but now it is concave down, and it is concave down parallel to z negative. Okay. Okay, so that is the function that we want to sketch just now. So next, how about if I put the square root? Okay, but before we proceed with the sketching, so let's count how many total variables that we have. So we got 3, so mean that you have to provide 3 traces. So equal to square root of x squared plus y squared. Okay, so as we done before this, we set the plane. We want to know what is the shape that we can see right on the x0 plane. So we set x equal to 0. So we have z equal to square root of y squared. And then y equal to 0 plane, we have similar function but different variable. They are the same, right? But different variable. Okay, now we want to sketch. So this one z versus y, and this one now z versus x. Okay, so please give me. So this one. So if you simplify this, y square and square root, so we will have just y, right? So now we draw it. Draw We have a straight line there. But now I'm asking you, is this correct? Is this line correct? Okay, now how can we know it is correct or not? So now look at the original expression here. So now the function given to you is already in the square root form. So meaning that this means z is always positive. So if you put the sketching like this, so is this correct? Of course not, because you extend the line here, meaning that you are also considering z is negative value. So that is incorrect. So we have to draw like that. Okay. Now back again to the original expression. Now look at the y here. Just focus the y square. You have to make sure that the value that you have here must be positive or equal to 0, isn't it? Right. Can I put y negative? Can I put, let's say, negative 1 and then square, negative 100 and then you square? Can we do that? Of course, yes, because for any negative value you put in to be the y value, so it is always become positive because you have to square after that. Let's say you put -1, so it end up to be 1. Let's say you put -2, it end up to be 4. It is always positive, meaning that y also can be negative, can be 0, and can be positive. So again, is this correct? So what do you mean by correct or not? Okay, now you read this. How can you read the graph? So you said that if you provide me just this line, so you said that z and y must be positive. For z is fine. Yes, we want z to be positive. However, the y can be negative with the condition that z should be positive. So how can you provide that line? So you just provide me that line. Okay. So it is a bit different with the previous where there is no square root. We have on the trace you have something smooth, right? Which is quadratic. But this time you have a sharp bend down here. This line, and then just like a mirror and point to that side. Okay, so that is the sketching on ZY plane. And for the ZX plane also we use the similar analysis. We use the similar reason. Okay, which means that you can say that I need Z to be positive. So should be all over here. The sketch should be on the first and second quadrant. But then X, can we consider X negative? Can we consider X 0? Can we consider X positive? Yes, you can. So again, yes, when you simplify, you have this one, which is Z equal to X. So your drawing is this one, and then because you want X also negative but Z positive, and you provide that line. Okay, then that is the traces, and then Z equal to 0 right on the floor. So what can you see? So you have X squared plus Y squared, so you have a square root here, equal to Z. Okay, which means that you can rearrange or you just divide that. So then when you set Z equal to 0, so your equation become equal to 0, and when you simplify, you have this form. So again, what is that? So you sketch the line on y-axis plane. So what is this? Just like the parabola just now, you have a circle centered at the origin with no radius. So you can see that we have only a single dot again. Okay, again we have no idea what is actually the shape that you can see from the above, from Z axis. Okay, now before we proceed with the level curve, so let's combine all the three traces on a 3D system. So I'm using the common orientation, the regular Y and this Z. Okay, now the first trace. The first trace tells you that you are standing along x-axis, because you can't see from this equation you can just see Z and Y, so meaning that you are standing on over here. So what is the line, the curve that you can see? So this is the curve that you can see. So you can see that line. Okay, make sure you have a sharp bend, not a curvy like this. So this one will give you paraboloid because you have a quadratic. Be careful when you sketch. Okay, so now we move to other side. Now you are standing over here and looking to that direction on Z-X plane. So when you see from the Y and you see over there, okay, so you can see another V shape. So this is for X positive and this is for X negative. It looks compressed, but actually the size of these two V shape, they are the same, because now we are watching from this side. Okay, the side from here, this one from in front. Okay, so from here you can see V shape, and then you move around, you can see the V shape. So now you imagine all the time you can see the V shape, V shape, V shape, V shape, right? Okay, now what can you see when you are standing along the Z? Which means that first you set Z equal to 0, but unfortunately you can just have a single dot. Again, it doesn't tell you. It tells you nothing. Okay, I mean in terms of the curve, we have no idea at all. Okay, so meaning that you have to again play around with the value of Z. Just now you said that I want to see the curve when we set Z equal to 0, which is right on the floor, but you can't see anything, just a dot. Okay, now we increase the Z. So just now we set Z equal to 0, so maybe I want to have 1 and then 2 and then 300 and so on. Okay, so now we just rewrite into this form. So x squared plus y squared square root is 0. Okay, and then I have x squared plus y squared square root is 1. And then x squared plus y squared, I got 2 and so on. Okay, so now rearrange. So you have x squared plus y squared equal to 0. It is a circle with no radius. X squared plus y squared equal to 1. It is a circle with radius 1. X squared plus y squared equal to 4. You have a larger circle with radius 2. So now when you sketch, okay, so this one, the sketching of these values of Z should be on the same y-axis plane, so that you can see what happened when you increase the Z or decrease the Z. If you sketch on a different y-axis plane, so you cannot see the pattern. Okay, so that's why you have to, it is compulsory for you to sketch this particular value of Z on the same 2D system, so which we call that as a level curves. Okay, so we have circle radius, no radius, so it is a dot, radius 1 and radius 2. Okay, now we have to level, so that is belongs to Z equal to 0, so we know that right on the floor we can just see a dot. And then when you increase Z by 1, you can see a larger circle with radius 1, and then a larger circle with radius 2, that is Z equal to 2. Okay, so now you can conclude that Now the surface should be, when I'm increasing the z, so the circle's also increasing. The size of the circle is also increasing. So now, based on your traces, so you have done combining these two traces and also a dot over here. And then you can see that by increasing the z, you can see circles, circles, and circles. And again, actually, the size of this particular surface is very, very, very large. Okay, so what call this? Just now we have a paraboloid a bit. There is smooth, okay, smooth. But now you a bit a sharp bend. So this is called cone. Okay, so now with square root we have a cone. Without square root we have a curve. Okay, so you have a cone. So now this is the graph of square root of x squared plus y squared. So this graph is z equal to, you have the cone, a cone concave up and parallel to, concave up and parallel to z. Okay, so maybe I change to y equal to x squared plus z squared. Okay, since you know that the basic of the cone is this one, so now you must have the similar cone. Of course, you have the same size of cone, but on the different orientation. Okay, which means now you just change. So you have y here, so you have a cone concave up and parallel to y. So you just change to this one becomes y, and this one becomes x, and this one becomes z. So you have a similar cone. Okay. Okay, how about by using the standard equation of a cone? Let's say I give you 1 plus square root of x squared plus y squared. Do we have a similar cone, the same size of cone? Let's say we have this particular cone, okay, and this one is z. So this is z. Okay, so my pencil is z-axis. So now where is the cone going to? So you have plus 1 there, meaning that it is shifted 1 unit above along the z. Okay, you still have the same cone. So now for you to sketch, so that is your cone. That is your cone. So this is z, and this is equal to 1. Okay, and similarly, if I change 1 minus square root of x squared plus y squared. Okay, so firstly, we are thinking about negative of z. So we have something like down, concave down, right? So that is it. So your cone concave down. So this is x, this is y. Now because you have plus 1, so you have plus 1, positive 1. So you shift the z, shift the cone 1 unit above along the z. So now it's become, so this cone move upward 1 unit along the z. Which color? Which color? Tell me. This one. So we have something like that shape. So this is x, this is y, and this is z, where z is equal to 1. Okay. So normally in exam test, final exam question, so they will modify all these basic equation. So what I mean by basic equation? So as I listed some equation here, especially for this one. Yeah, this one we know that it's a sphere, so it is basic. And this one we have just now we obtained that one is a ball or hyperboloid, and this one is a cone. What else? And this one also basic. That is a I would say a drain shape. Drain longkang drain. What is the drain looks like? You have something like this. Something like that. The drain shape. Sorry, my sketching is very bad. Okay, drain shape. Okay, the last one. Again, the total variable is 3. So the 3 should be also 3.